This video is going to be an introduction to factorial, and we're going to try and take an intuitive approach. So let's consider a running race between 5 people. Say person A, person B, person C, person D, and person E. Now let's have a think about how we would go about counting the number of ways that this race could finish. Well, before the race, anyone can win. Before someone's won, anyone could win. So if we think back to our last video, and when we were listing outcomes and counting possible outcomes, there are 5 possible outcomes for somebody to win. It could be A, B, C, D, or E. So that's event 1, we could look at it as, or task 1. Now, let's think about what happens after someone does win the race. Let's say it could be anyone, but let's say person B wins the race. Event 2 would be who comes in second place. But since B has finished the race, they're out of the race. There are only 4 possibilities for someone to come second. So there are 4 outcomes for second place, right? That's 4 outcomes to event number 2, we can look at it. So 5 for event 1, someone coming first, 4 outcomes for event 2, someone coming second. But then once someone's come second, there are only 3 people left in the race. Therefore, only 3 people can possibly finish in third. We can almost start to see a pattern here. 2 possibilities for someone coming fourth. And then once there's only 1 person left in the race, they're obviously going to come last. So there's only 1 possibility for the person who's coming in last once the other 4 people have finished. So like in the last video, where we have a certain number of events happening in turn, someone coming first, second, third, fourth, then fifth, those can be seen as 5 events that have happened in turn. We now can use our formula from the last video, where we multiply the possible outcomes for each event to get the total number of outcomes to the situation. So as we said in the last video, we just multiply the number of outcomes in each scenario together. So 5 possibilities for first, 4 for second, 3 for third, 2 for fourth, and 1 for fifth. So 5 times 4 times 3 times 2 times 1 is equal to the number of ways this race can finish. There is a special term for this kind of product, and it's called factorial, and its symbol is an exclamation mark. So 5 times 4 times 3 times 2 times 1 is equal to 5 factorial. That's how you say it, 5 factorial. And in this case, this sum is equal to 120. The proper definition is the product of an integer, which is just a whole number, and all the integers below it. A quick note here, 0 factorial is 1. Seems kind of strange, but yeah, that's the thing to remember. 0 factorial is 1, but any other factorial, so 1 factorial would just be 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. But yeah, so what's the point of this factorial? What's the point of doing it? Well, it's useful because n factorial tells us the number of ways of arranging n things in a line or in an order. So in the race example, the number of ways that race could finish, we can see that as the number of ways that people can be lined up. That would be, if it's like in this case a 5-person race, that would be 5 factorial. If there's 20 people in the race, the number of ways that race could finish is 20 factorial. How many ways are there to order 6 people in a line? You could also view this as a 6-person race. How many ways are there for this race to finish? Because those people are coming in a certain order. Well, just as what I've written just above here pretty much tells us the answer. N factorial tells us the way of arranging n things. So arranging 6 people would just be 6 factorial. Like that, which I believe is 720. And this is completely in line with the logic we've been using before, the reasoning we've been using before, the counting arguments. So there are 6 possible people that could go in the first position. So if this is the first spot here, 6 people could occupy the first spot. But once someone's in there, only 5 people can occupy the second spot, and so on and so forth, down to 1. And like I said, you would multiply all, and that, as we've just learnt, is the definition of factorial, 6 times 5 times 4, or a number times all the numbers below it. The last example of this video we're going to go over, a little calculation, 7 factorial divided by 6 factorial. This might look a bit confusing at first, but it's actually it's a surprisingly simple calculation if we write out what 7 factorial is and what 6 factorial is. So we know 7 factorial is 7 times all the numbers below it. So 7 times 6 times 5 times 4 times 3 times 2 times 1. And if we divide that by 6 factorial, we're writing it all out. 6 times 5 times 4 times 3 times 2 times 1. You can clearly spot here that cancellation takes place. The 6's cancel, the 5's cancel, the 4's cancel, the 3's cancel, the 2's cancel, and the 1's cancel. So 7 factorial divided by 6 factorial is equal to 7. So yeah, that concludes our introduction to factorial. with sort of an intuitive approach, so hopefully that gives you some sort of understanding. We'll be going into more detail in other videos, but that's a good starting point. Right, thanks for watching.